Okay, this is sample problem 14.4. The decomposition of hydrogen peroxide is first order in H2O2. The balanced equation is 2H2O2 aqueous is converted into 2H2O liquid plus O2 gas. The rate constant for this reaction at 20 degrees Celsius is 1.8 times 10 to the minus 5 reciprocal seconds. And if the starting concentration of H2O2 is 0.75 molar, determine the concentration of H2O2 remaining after 3 hours and how long it will take for the H2O2 concentration to drop to 0.10 molar. Okay? If it's a first order reaction, and it says in the question, this is the decomposition of hydrogen peroxide is first order. Then there are two equations that I've already written at the top here that we can use to analyze the kinetics of that reaction. The one on the left says that the natural log, ln, of the ratio of the concentration of the reactant, A, divided by the initial concentration of the reactant A is equal to minus kT. So A is the reactant. So we can substitute in H2O2 because that is the reactant. The little 0 sign next to the A in the bracket just means initial. Okay. The natural log of that ratio is equal to minus kT. K is the rate constant, and T is the time. An alternate form of the equation is written to the right. All I've done is I've separated out the natural log terms, A and A naught, so that we now have ln of A minus ln of A naught, or A0, is equal to minus kT. So we can use either of those two equations, and we'll pick the one that is more convenient for us. So let's look at part A. It says the rate constant is 1.8 times 10 to the minus 5 reciprocal seconds. So K is equal to 1.8 times 10 to the minus 5 reciprocal seconds. Remember, that means 1 over seconds. The rate constant for first order reactions is typically 1 over time units. If the starting concentration, well, starting means initial. So if the starting concentration of H2O2 is 0.75 molar, okay, well, right there, that tells us that the initial concentration of A is 0.75 molar. Okay. Now we're using H2O2. That's fine. I'm just going to go ahead and use A, the symbol A, to represent H2O2. It's just easier to write it. If the starting concentration of H2O2 is 0.75 molar, determine the concentration of H2O2 remaining after 3 hours. So now they're telling us that the time is 3 hours. Okay, well, I'm going to convert that to seconds because the rate constant is not in terms of reciprocal hours, it's in terms of reciprocal seconds. So I'm going to convert that, multiply it by 3,600 seconds per hour, and you get, what was that, 10,800 seconds. So there's our time. Now in part A, we want to find the concentration of H2O2 remaining after these 3 hours. So really what we want to know is, what's the concentration of A? Okay, that's our question right there. So we're trying to figure out what this is. Well, that's a little tricky because the way this is set up, we have a natural log, and it's the natural log of A in the formula, in the equation. It's not A equals, it's ln of A. So we have to take that into account. I'm going to actually take a look at this one over here on the right, because if we're just trying to find out what A is, really what our strategy will be to figure out what that term is right there. And that term is separated from the A naught, whereas here it's a ratio. They're not really separated, they're together. So I'm going to use the one on the right. Algebraically, if we want to find out what A is, we have two terms on the left side, ln A and LAA0. let's just add ln a0 to both sides, and we'll have ln of a equals minus kt plus ln of a0. Okay, so I've added that to both sides. Now I'm going to go ahead and put the numbers in. So it's minus kt, so minus 1.8 times 10 to the minus 5 reciprocal seconds. That's minus k. T is 10,800 seconds. And then we're going to add ln of a naught. A naught is 0.75. Okay. So now that will give us ln of a, natural log of the concentration of a. And let's go ahead and do the computation. 1.8 times 10 to the minus 5 times 10,800 is 0.1958, but there's a negative in front of it, so it's 0.1958. And then we want to add to that the natural log of 0.75, ln. So that's minus 0.2877. Okay, so if you're taking these two numbers and you're putting them together, they're both negative, so it's 0.1958 negative plus 0.2877 negative, and it looks like it's negative 0.4835. Now we want to find a, not ln of a, but a. So a, how do we deal with that? The inverse function of natural log, if you want to figure out what x is, what you would do is you say e to the ln of x. That gives you x. So you got to do e to both sides, e to the y. So same thing here. A naught would be e raised to the minus 0.4835. Okay? So that's the exponential function. Sometimes on your calculator it's written as exp. So 0.4835. And then you want to do e to the x. Oops. 0.4835. E to the x. And that's 0.617. So there you go. So what's happened is after 3 hours, it's gone down to 0.617 molar. That's 3 sig figs. I guess we could round it to 0.62 molar. Okay? First order. Now if it's second order or zero order, you have to use different formulas, different equations. But if it's first order, that's what we would use. Part B, how long is it going to take for the concentration to go down to 0.1 molar? Now that, in this case, this might work, this equation right here, because now we know both these numbers, 0.1 and 0.75, and we're just trying to find out what t is. So what I'm going to do is I'm going to rewrite it over here. A over A naught equals minus kt. So notice I drop the bracket notation. It's very common to do that with these formulas. It's not always that people do, but boy, these brackets get so tedious. There's so many of them. So sometimes we'll just drop that out. So let's go ahead and put in ln of 0.10 over 0.75. And that's equal to minus kt. Well, k is 1.8 times 10 to the minus 5. So minus kt. Well, we want to find out what t is. So what we got to do is we got to multiply both sides by minus 1. And then we have to divide it by k. So minus 1, so ln of 0.10 over 0.75. So I've multiplied both sides by minus 1, and then I'm going to divide it by k. And that'll give us t. Okay, so a lot of arithmetic there. 0.1 divided by 0.75. So find that ratio. That ratio is 0.1333, 0.1 over 0.75. Then take the log of it, ln. That gives you a negative number. The natural log of a number less than 1, between 0 and 1, is negative. So it's going to give us negative 2.0149. But it's not the natural log of the ratio, it's the negative natural log. So multiply it by -1. And that's going to give you positive 2.015. Then divide it by 1.8 times 10 to the -5. And that's going to give you this big number. I'm going to put it in scientific notation. 1.1 times 10 to the 5. And then our units are going to be seconds. Okay. Now, it did not ask in the question how many hours it's going to take for that to happen. It just said how many seconds. So that would be our answer in seconds, 1.1 times 10 to the 5. Okay? There you go.